Very good morning, students, and welcome to the digital classroom of science. Dear students, many of you are coming to the school physically and enjoying the teaching inside the school classroom. We are eagerly waiting for the remaining students also to come and attend the school. So, students, today we are going to start with a new lesson, lesson number 14, measurement and effects of heat. So, let's start with the lesson. Students, we had studied in the previous standards that heat is a form of energy and it always flows from an object which is at high temperature towards an object which has a low temperature. That is, it always travels from high temperature to a lower temperature. And by observing the temperature of an object, we can tell whether the object is hot or cold. The cold object temperature is quite low compared to the temperature of a hot object. So if we compare between ice cream and tea, we will say that the temperature of ice cream is less and the temperature of tea is high. Okay. Then we had also studied in the previous class that if heat is applied to an object, it expands, it becomes bigger in size, and when heat is withdrawn from it, it comes in its original shape and size, right? So the heat allows the object to expand and contract, as well as the heat, if is applied, it changes the state of matter also. That also we had studied in the lower classes. Now, how the heat is measured, in what unit? The unit of heat in SI system is joule, and CGS system it is measured in calories, and 1 calorie is equal to 4.18 joule. Next, we will study what are the sources of heat. From where do we get the heat? And the very first natural source of heat is sun, right? We all get heat from the sun, and it is the biggest source of heat received by the earth. Now, inside the sun, the nuclear fission takes place, right? Because of it, a large amount of heat is generated in the center of the sun. Now, in this process, the hydrogen nuclei, they fuse together and they form helium nuclei. That is, the hydrogen nuclei, they fuse together, they combine together and they form the helium nuclei, and thus in the formation of these helium nuclei, a large amount of heat is generated. Now, this light is reaching to us in the form of heat as well as in the form of the light. Then the second source of heat is the earth itself. Now, as you know, the temperature at the center of the earth is high, and it is also a source of energy, heat, right? And this heat which is there in the center of the earth, that is called as geothermal energy. The third source of heat is the chemical energy. Now, when we burn the fuels like wood or petrol or coal, all these, when they are burnt, when they come in contact with the oxygen, combustion takes place and a chemical reaction takes place between the oxygen and the fuel, and heat is generated in all these reactions. The next source of heat is the electrical energy. In our day-to-day life, we see that several electrical gadgets, equipments, they produce heat with the help of the electricity, like the electric water geyser, then electric heater. So electricity is also a source of heat. The next is atomic energy. Now, a large amount of heat is produced in a very short span of time when the nuclei of some radioactive elements like uranium, thorium, they undergo fission, right? And this is called as the atomic energy. Next source of heat is air. Now we know that a large amount of heat is present in the air around us. Everywhere this heat is present in the air. The next we are going to start is the relation between the heat and the temperature. What is the difference between heat and temperature? Now we know that all the substances are made up of atoms, and these atoms are always moving. They always keep on moving from one place to another, and they move because of the kinetic energy. Now, the total kinetic energy of the atoms which are present in the substance, it is measured by the heat which is present inside the substance, right? That means the kinetic energy depends upon the heat which is present in the atoms or in that substance, and the temperature is related to the average kinetic energy of atoms. Now let's try to understand with the diagrams which are given on the screen. Now figure A and B, they show the velocities of atoms in a gas at high temperature and low temperature. That is, A is having high temperature because it is hot, and B is having low temperature because it is cooler compared to the A. Now the direction and the length of the arrows which you can see, they are attached to the atoms. They show the direction and the magnitude of the velocity of the atoms, right? The velocity of atoms in the gas are higher than the velocity of atoms in the gas at lower temperature. That means the velocity depends upon the temperature. The higher the temperature, the higher the velocity, right? Then the atoms, when they are present in a solid object, they are very close to each other. They have a very strong intermolecular force, and because of that, they cannot move from their place. They cannot be displaced. But when heat is supplied to it, these atoms, they start moving around in a fixed position. And as we increase the temperature of the solid, the velocity of these atoms increases. Okay? Then next, we will study about the temperature. Now we'll just see one experiment. We have to take two vessels, two beakers in which we have to fill water. In the first beaker, we have to take half the amount of water, and in the B, we have to take double the amount of water. And we will observe when we heat these two beakers, we will see that to raise the temperature of the second beaker, we need more amount of heat, right? Because the amount is more. The water in the second beaker is double the water present in the first beaker, and thus the double amount of heat is required to raise the same amount of temperature in both the beakers. Temperature is measured in units of Celsius, Fahrenheit and Kelvin. These are the three units of measuring the temperature. Kelvin is generally used in scientific experiments, whereas Celsius and Fahrenheit are used in our day-to-day life. Now, what is the relation between Celsius and Fahrenheit as well as Kelvin? Now, if we compare, we will see that F minus 32 upon 9 is equal to C upon 5. This is the relation between the Fahrenheit and C. C is Celsius and F is Fahrenheit. And if we see K, K is equal to C, that is Celsius, plus 273.15, right? So if we add 273.15 in Celsius, we will get the Kelvin. The next we are going to study about the thermometer. Thermometer, every one of you might have seen, might have used in our day-to-day life. If someone gets the fever, we generally use a thermometer to measure the temperature. There are different types of thermometer. We'll study about the first type of thermometer. Now here you can see that the thermometer is made up of a narrow glass tube which has a bulb at one end, and the bulb and part of the tube is filled with a liquid. Now in the earlier times, mercury was used as a liquid, but nowadays it has been replaced by alcohol. Now the volume of the tube has vacuum and its other end is closed. Now when the bulb, the lower end of the thermometer, is kept in contact with the object, the temperature can be measured with the help of the thermometer. Now because of the increased temperature, the alcohol which is present inside, it expands and its level in the tube rises, right? Now this happens because of the property of expansion of alcohol. The temperature can be noted. Then the second type of thermometer is the clinical thermometer, which is generally used by us to measure the temperature. Now we know that the body temperature of a healthy person is 37 degrees Celsius. So clinical thermometers are designed to measure temperatures between 35 degrees Celsius and 42 degrees Celsius. Nowadays, the digital thermometers are used for clinical purposes. As you can see on the screen, where directly the digits can be read in the thermometer. So they are not calibrated like the earlier ones, but now they show the digital temperature. Then the thermometers which are used in the laboratory, they are similar to the thermometer which is shown in the latest picture. They have a range of temperature that can be measured from 40 degrees Celsius to 110 degrees Celsius. So the minimum temperature can be 40 degree and maximum 110 degrees Celsius can be measured by this type of thermometer. The next topic we are going to start is the specific heat, and it is denoted by the symbol C. Now, the specific heat of an object is the amount of heat required to increase the temperature of unit mass by 1 degree Celsius. Okay. So, if we want to raise the temperature of an object by 1 degree Celsius, then the amount of heat required is called as the specific heat, and it is denoted by C, and it is measured in SI system by joule, that is kilogram degree Celsius, and in CGS as calorie per gram degree Celsius. Now, suppose Q amount of heat is required to increase the temperature of an object of mass m and specific heat C, and the temperature rise is Ti to Tf. Right? Now this depends on the mass and specific heat of the object as well as on the increase in temperature. Now different substances have different specific heat. So different substances, different objects have a different specific heat. They need different amount of heat to raise the temperature by 1 degree Celsius. So if we represent mass with m, specific heat with c, and the temperature Ti and Tf, then this increase in temperature can be written as Q is equal to m into C into Tf minus T1. Okay, Q is the rise in the temperature, m is the mass, C is the specific heat, and Ti and Tf are the two temperatures, that is I initial temperature and F is the final temperature. Now as I told you that the different substances have different specific heat. You can see the different metals like aluminium or liquids like alcohol, gold, they have the different specific heat. Next we are going to study about the calorimeter. Now calorimeter is used to measure the heat content of an object. With the help of this calorimeter, we can measure the heat which is produced or which is observed in a physical or in a chemical process. Now, as you can see the structure of the calorimeter, it is almost similar to a thermos flask and it has two vessels, one inner vessel and the other one is the outer vessel. So because of these two vessels, there are no chance of heat to be transferred from the inner to the outer or from the outer to the inner vessel. So the inner vessel is isolated, completely isolated from the surrounding. The inner vessel is made up of copper and a thermometer is placed in it to measure the temperature, and we have a stirrer which is used to stir the liquid in which the calorimeter is fitted. Now water is placed in the calorimeter. So the temperature of the inner vessel and that of the water in it will be the same. And when we place an hot object in the water, heat will be exchanged between the hot object and the water. Right? Now, as this calorimeter is thermally isolated from the surroundings because of these two vessels, the total heat lost by the object is equal to the total heat observed by the calorimeter and water inside it. Okay, so this is how it works. Now, these are the symbols which are used for the different units. Mass of inner vessel is denoted by mc, initial temperature Ti, mass of water mw, temperature of water Ti, mass of object mo, temperature in calorimeter To, final temperature Tf, total heat given, that is Qo. Q is the specific heat, and heat gained by calorimeter Qc, and heat gained by water Qw. And thus we get the equation which is Q0, that is total heat given, is equal to QC, that is the heat gained by calorimeter, plus heat gained by water, QW. Okay. The next we are going to study about the effects of heat. We had already studied in the lower classes that there are two effects of heat on matter. The first one is expansion and contraction, and the second one is the change in the state of matter. So in this lesson we are going to learn more about the expansion. Now first we will start with the expansion. As I said, this we are going to study in the 8th standard. When heat is given to any substance, its temperature increases and it expands, it becomes bigger in size. Now this expansion depends upon the increase in its temperature, or in simple words we can say it depends upon the amount of heat which is supplied to the object. Now all the three states of matter, that is solid, liquid and gases, they all expand when the heat is supplied to them. Now we'll study about the expansion of all these three states of matters one by one. First we will start with the solids. Now in solids, the expansion is called as the linear expansion. So the linear expansion of a solid is the increase in the length of a wire or in the rod in a solid state due to increase in its temperature, and thus it is called as linear expansion. Now students, these formulas are quite difficult for you, so please don't go in depth. It is just given, and all these complicated formulas are being deleted this year from your syllabus due to the corona pandemic. So that is, I have shown you, you should know about the formula, but no need to go to the depth of it. Now L is the length, right? And the inverted Y is pronounced as lambda. And this lambda is the constant of proportionality, and it is called the coefficient of linear expansion of the solid substance. Now this is the formula to find out the lambda or the linear expansion, that is L2 minus L1, that is the original length and the final length, and divided by first length, that is the original, and the change in the temperature. Okay. Now as you can see in the table, the different solids have different linear expansion. They have different coefficients of linear expansion. The next is the liquids, expansion of liquids. Now we know that the liquids do not have a definite shape, but they have a definite volume. So we can define the volumetric expansion coefficient with the help of the following equation. V2, that is the second volume, is equal to V1, the original volume, 1 plus beta, change in the temperature. Triangle T means change in the temperature, and beta is the coefficient of volumetric expansion of liquid. Just it is for your understanding. No need to get scared looking at this equation. Okay. And the last one is about the gases. Now we know that gases, they neither have a fixed volume nor they have a fixed shape. And if they expand, if heat is provided to them, they expand, and if they are kept in a closed box, then the volume cannot increase, but then the pressure increases. Now this can be explained with the help of this simple diagram. In the picture you can see we have two bottles. In the first bottle the piston is fixed, and in the second bottle the piston is movable. Now the amount of air in both the jars, both the bottles is same. Now when we supply equal amount of heat to both the bottles, we can see that the motion of the molecules increases. Now in the first bottle, the piston is fixed, so it cannot move. So in the same given area, the pressure increases. Whereas in the second bottle, the piston is movable. So when heat is supplied and the molecules, they start moving with more kinetic energy, they push the piston and the pressure on these molecules becomes less, right? So when a gas expands, if the volume cannot be increased, the pressure of the gas increases. And this can be find out with the help of this formula. V2 is equal to V1, 1 plus beta, change in the temperature, and beta is the constant pressure expansion coefficient of the gas. So students, with this we finish up with the lesson. Whatever I have not taken in the lecture, that is deleted due to the corona pandemic. In the beginning of the year also I have told you, and again I am reminding you, from certain lessons some portion is deleted because we have less time this year, and thus that will not be asked in the exam. So students,